Hi, Mr. Sevilla. So me and Rose are gonna do number 8. So this is the graph for this is what's given for number 8 is the original function, and we're going to find the first derivative and second derivative of the function. So first we need to determine where the x-intercepts are for the first derivative, and we can find that by figuring out where the tangent line is equal to 0 on the original function. So as you can see, the tangent lines are here, 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 and here. So at these points are where the derivative will be equal to 0, or where the x-intercepts are. So if we draw the dotted line down, we can see that its x-intercepts are right here at these points. Okay, next we determine where the graph is increasing and decreasing, or which intervals the graph is increasing and decreasing. So we can see on this part of the interval of the graph, you see that it's increasing. So here, over from here to here, it's decreasing. So we label like that. It's increasing, so positive, and over it's decreasing, so negative. From here it's increasing, so it's positive. So these signs tell you where the graph is going to be positive and where the graph is going to be negative. So where it's above the x-axis, where the graph is below the x-axis. So over here, since it's positive, that means the graph will be positive at this interval. So it looks something like this. Over here it's negative, so it's going to be below the x-axis. So like this. Right here it's positive, so it's going to be above the x-axis. Here it's negative, so the graph is going to be negative. And over here it's positive, so it's going to be positive at that part of the graph. Okay, so that's our f prime.
Okay, so we know that the minimums and the maximums of f, the derivative of f will be the zeros for the second derivative. So we have to draw dashes here to indicate where the zeros are. So these will be your zeros for second derivative. And now we need to figure out how the graph of the first derivative is acting. So we figure out if the graph of the second derivative is going either up or down, negative or positive. So you see here this is negative, you see here that this is positive, you see here this is negative, and this is positive, and this is negative again, this is positive. So now we could draw the graph based off of the characteristics. So we could put an arrow right here, because this is positive, it will be in the top axis. So then now we draw graph down because this is a negative slope, so we draw it down until we hit the 0 over here, and then we need to draw it up again because the slope right here is positive, and that intersects with our next maximum, and then it goes down again because the slope over here is negative, so then that intersects with the next 0, and it goes up again because of the slope of the other graph right here, and it goes down again. Voila, Mr. Sevilla. Easy, right?